Okay, so we're going to continue studying about solving systems of linear equations. Today we're going to learn a new method of using elimination. We're going to be using multiplication now in elimination. So I want you to take a moment, pause the video, read through the content standards and our mathematical practices we're going to be using through our exercises. So previously we've used elimination with addition and subtraction to solve systems of equations. Today we're going to solve systems of equations by using elimination with multiplication, and we're also going to solve some real-world problems involving systems of equations. Our key concept in solving by elimination, we're going to multiply at least one equation by a constant to get two equations that contain opposite terms. Step 2, we're going to add the equations, eliminating one variable. Then we're going to solve the equation. And finally, in step 3, we will substitute the value from step 2 into either one of the equations and solve for the other variable. We will write the solution as an ordered pair. So our first example, we're going to multiply one equation to eliminate a variable. So looking at our equations, we have 2x plus y is equal to 23 and 3x plus 2y is equal to 37. Notice that neither of the coefficients, whether x's or our y's, are the same or the additive inverse of each other. So we've got to do a little work first before we can get started. So we're going to multiply our first equation by -2 so that our coefficients would be additive inverses for our y terms. So 2x times a -2 is -4x, y times -2, -2y, and 23 times a -2 is -46. Now all we need to do is set it up as our two equations as a column and add them together. We're left with -x is equal to 9. So we're going to divide both sides by -1 so that x is equal to 9. Now we're going to substitute 9 in for x. It doesn't matter which equation we choose. Here in this example, they're using the first equation. So instead of x, we're substituting in 9. So we have 18 plus y is equal to 23. How do we solve for y, folks? You're right. We're going to subtract -18 from each side. So y is equal to 5. So our solution is 9, 5. Now, time to try it for yourself. So I want you to read the problem, pause the video while you work the problem, decide which answer you're going to choose, and then restart the video to check to see if your answer is correct. Awesome. 5, 1. So you have to pay very close attention. It's very easy to get those two mixed up. So x is always listed first, y is second. Ooh, now it doesn't matter if what we multiplied this one by, we could never get one of these terms. Or no matter what you'd multiply this by, you couldn't get one of these terms. So what we're going to have to do is multiply both equations by something. So method 1, we're going to try to eliminate the x. So we're looking at our coefficients with our x values. We are going to multiply the first equation by a +3 and the second equation by -4. That way we have opposite additive inverses for our coefficients for x values. 29y is equal to 116. Divide both sides by 29. Our y is 4. Now we need to substitute a 4 in place of y in either equation. It doesn't matter which one you choose. They're choosing the first equation here. So we're going to have 4x plus 12 is equal to 8. Now we're solving for x. So we have to subtract 12 from both sides. Then divide both sides by 4. So x is a -1. So our solution is -1, 4. Now, this time we're going to look at the same system of equations, but this time we're going to eliminate y. So we're going to multiply the first equation by 5 and the second equation by 3. Now, if I had to choose at the beginning, if I only had to do it once, this is the method I would choose because I see that these signs are opposites. So then I'm not messing with as many negative numbers. So doing the multiplication, setting the equations up in a column, we're going to have 29x is equal to negative 29. Divide both sides by 29, we get x is equal to negative 1. Now we're going to substitute a negative 1 in for x in either one of these equations. It doesn't matter. In our example here, we're choosing the first equation. So we have negative 4 plus 3y is equal to 8. We're going to add 4 to both sides. That leaves us with 3y is equal to 12. We divide both sides by 3. Y is equal to 4. So our solution is negative 1, 4, and that matches the result that we obtained in method 1. So it doesn't matter which way you decide to solve, which variable you decide to eliminate, you're going to get the same answer. Time to check your progress. You get to choose which one to eliminate. Pause the video, read through the problem, choose your answer, then restart the video to check to see you're right. Awesome, 4, negative 1. So no matter which way you decided to go solve this system of equations, you should have gotten the same answer. Let's look at a real-world example. And let me tell you, folks, you're going to be solving problems with this fishing boat all the way through college algebra. Actually, if you take pre-calculus, you're going to be calculating the current of fishing boats or rowboats or whatever. So pay very close attention. This is extremely important. We have a fishing boat that travels downstream in 30 minutes. The return trip takes the boat 40 minutes. Find the rate in miles per hour of the boat in still water. So we're going to let B be the rate of the boat in still water. That's what we're trying to find. C is the rate of the current, because notice it takes longer to get back upstream than it does downstream. We're going to use the formula rate times time equals distance, or we've learned it as distance equals rate times time, the DIRT formula, remember that? Since the rate is miles per hour, we're going to need to change 30 minutes to what it represents in an hour. 30 minutes is a half of an hour, and 40 minutes is 2/3 of an hour. So we're doing a little work up front. So you make yourself a little chart. Downstream, you got the current helping you out. Upstream, you're going against the current. We're going to use elimination with multiplication to solve this system. So since the problem asks for B, let's eliminate C. So we're going to multiply the first equation by 2/3, the second equation by 1/2. We're going to have 4/6B is equal to 35/3. Take just a moment. You remember how we solved for B? What do we have to do? So good. We're going to multiply both sides by the multiplicative inverse of whatever's with the variable. So we've got 4/6 with the variable. We're going to multiply both sides by 6/4. Simplify. We've got 17.5 is what B is equal to. So the rate of the boat in still water is 17.5 miles per hour. Now it's time for you to check your progress. So read the problem, pause, work the problem, and then choose your answer. Restart the video to see that you're correct. 105 miles per hour. So if you didn't get that, go back and look at some of your work. Did you make just a little error with your signs? I bet you got this one. Okay, good job. It's time for us to group together and work on our exercises.